Hello everyone, welcome back. In this video we are going to continue exercise 6.2 of triangles. So this chapter is based on similarity of triangles. First exercise I have already uploaded and I have shared the link in the description box. You can, if you have not seen that video, you can check out that video also. And now this exercise will start by doing two theorems. We have to do the proofs of the theorems and then we'll continue with few sums. So let's start now. So you can see this is theorem 6.1 and the statement of the theorem is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. So what is this? So I have drawn one triangle, which is I can say this is triangle ABC. So what they have given in the statement, that if a line is drawn parallel to one side of a triangle, so we have drawn line DE which is parallel to third side of triangle, which is BC, and it is visible that DE is parallel to BC. So this is given in the theorem. Then so they have mentioned, if a line is drawn parallel to one side of a triangle to intersect other two sides in distinct points. So this line is intersecting other two points at these points, you can see at D and E. So then the other two sides are divided in the same ratio. So what they have given, and what first of all they have given us, so whenever you are doing a proof of a theorem, just start by writing all the given things. So first of all they have given us that this line DE is parallel to BC. This they have given in the theorem. Then they have given us, so this is what they have given us. Now let's see what they want us to prove. So three things you always have to write, or four things I can say. First of all, you have to write all the given things, then you have to write what you have to prove in the theorem. Then at the end you have to write if you are doing any construction while proving this, and then at the end you can start by writing proof. So to prove, this is thing we have to prove. Then the other two sides of a triangle are divided in the same ratio, which means AD upon BD is equals to AE upon EC. See, if a line is drawn parallel to one side of a triangle and this line is intersecting other two sides also, then the other two sides, they are divided into same ratio. This thing we have to prove, that AD upon BD is equals to AE upon EC. So this we have to prove. Now let's do the construction part. Construction means if you are doing any construction before doing the proof. So what we will do here we'll join so we'll just extend point E on AD, or we can say that we are drawing perpendicular from E on side AD. Here also we are drawing perpendicular from D on side AE. So this is the construction part which we are doing. Also we are joining DC and we are joining BE. So these constructions we have done. So you can write, this is also you have to write, you can write we are drawing EN, because we have written N point there, perpendicular to AD, and we have drawn DM perpendicular to AE, DM perpendicular to AE, or simply you can write we are drawing altitudes of this triangle, because perpendicular means straight lines, and straight line if we are drawing in a triangle, that will tell you the height of the triangle, means altitude of the triangle. So this was the construction part, and we have also joined DC join DC and BE. So this is the construction part. Now let's do its proof. So whenever you are doing proof of any theorem, you have to start in this way. So now let's start with the proof. So you have to see what you need. You need this thing, which means these two sides you need AD upon BD. AD and BD. So select these two triangles in which these sides are present. First I will select this full triangle. I will draw here also triangle because I need side AD. That's why I am choosing this triangle ADE, and I need BD also. See, that's why I'll choose this triangle also. This one. So this is how I have to start, by looking what I have to prove. In that way I have to choose which thing from where I can start. So I'll choose these two triangles. So I will write, because I have drawn altitude of the triangle, so I will take point E at the top. So I'll just rotating the triangle and I am drawing here. So it will be like this. So their point N is there. And then I am choosing this triangle also. This is some very slant triangle. So the side which I need, I will draw in this way. So here also, if you see, for this triangle also, its altitude is En. It's just outside, but straight line is always altitude of triangle. If you see this line, this triangle, this is straight line, but anyhow it's outside this thing, but still En is the altitude of this triangle. So I'll name it now En. Here it is D and here it is B. You can see BD, if we extend it, I can get the altitude of this triangle also. So I have drawn triangles in this way so that I can use these triangles, I can use results from this triangle and I can immediately do it without any mistakes. So in triangle ABAED, first of all I'll do for this triangle AED, area of triangle AED. So formula of area of triangle we will apply here, which is half into base into altitude. The base of the triangle, we will look here and we can see easily, we can locate its altitude also and its base also. So its base is AD. I will write over here AD, and altitude is perpendicular line is altitude also, because it's a straight line and it will give you the height of the triangle. So its altitude is En. So I'll mark this as my point number first. Now for both the triangles I will write this. First of all I have done for this. Now here I will do, I'm sure you have noted down this thing. So here I will write now area of triangle BDE. Area of triangle BDE. I have already used this, now I will use this. So again formula of area is half into base into altitude. So half into, what's the base of this triangle, which is written here, this is BD, into altitude. See, altitude, it will remain straight line. So En is the straight line which we can see in this triangle also, although we are getting by extending point D, but still En is the altitude of this triangle also. So I will write En. So this I will mark as 2. Now I have point 1 also and I have point 2 also. So what I will do, I will divide first and second. So why divide? Because I need AD by BD. So whatever you need, you have to act accordingly. If I am dividing this thing, AD I will get at top and BD at as my denominator. So that's why I am dividing. So whichever things you have written on left side, like area, that you have to write on left side, and whichever things you have written on right side, just write on right side. So I just need this point, area of BDE. This is my second, so I'll erase this now. So first by second I have to divide. So first one is area of AED. So I will write area of triangle ADE. Left side things should be written on left side, divided by area of triangle BDE is equals to all these values. As it is, you can write this ADE is half into AD into EN, and this area is half into BD into BD into EN. So this is what we have got. EN and EN, it will get cancelled because both they are same. 1 by 2 and 1 by 2, it will get cancelled. So now I am left with area of triangle ADE over area of triangle BDE. This is equals to AD upon BD. So this is one result. I'll just will give it point number 3. So step by step I have to write everything because we will be needing all these points. That's why we have to mark all the points as 1, 2, 3. So till here we have got this thing. So this thing I have got AD upon BD. Now I need AE upon EC. So we'll use different triangles in which I have these two sides, AE and EC. So again I will draw two rough triangles. In which these two sides are present. So first triangle, again this one ADE. Why this one? Because I need AE now. So again I will use this. So whichever side, since in area you need altitude, so draw in such a way that altitude it will come to this side. So now DM will be the altitude. So side is AE. So you have to draw a triangle in such a way so that easily you can locate all the sides. Now I need EC, AE upon EC. So I will use now this triangle. So I will draw here. This triangle is somewhat like this. So altitude again I will get outside of this triangle on extending the side. Altitude will be DM. If you see this triangle, if you are extending point E, you will get this altitude. So here it will be E and here it will be C. So these are the two rough diagrams. So if you draw triangles like this, easily you can write all the sides whichever you need in the proof. Now let's do. So we'll start the same way like we have started earlier. First we'll use area of triangle ADE will choose. So this is half into base into altitude. So this is formula. Base is, you can see its base, this lower side, it is AE now, and altitude straight line which is perpendicular, this is DM. So this is area of triangle ADE. We'll mark this as fourth point because till third we have already marked. So this will be a fourth point. Now let's find the area of triangle DEC. DEC. Formula it will remain same, half into base into altitude. So half base, the side which is here, downward side we can say it is base, which is EC, and altitude again straight line which is perpendicular also, so it is DM. So its altitude also we are getting by extending our EC, because we cannot take slant line as our altitude. Altitude it should always be a straight perpendicular line. So we extended this line EC and we got altitude of this triangle as DM. From here also you can see this is slant line and this will become right triangle. So here you can mark it as fifth point. Now same thing we will do, because we need this thing in ratio form. So again we will divide point fourth and fifth. So this triangle we don't need now. So you have to divide now. Left hand side things should be kept on left hand side and right hand side things it should be kept on right hand side. So we are dividing these two. So what I will get, because you need AE at top, that's why AE side I am keeping on top. I am dividing, you have to write divide fourth and fifth. So I will do it. Area of triangle ADE, first I'll write this, upon area of triangle DEC. So everything it should be correct. Just keep on checking yourself whether you are writing correct sides or not. So I'll fill the value half into, its value is half into AE into DM. So I'll write over here, and its value is half into, you just have to see from here, half into EC into DM. So same way 1 by 2 and 1 by 2 it will get cancelled, DM and DM it will get cancelled. So I am left with area of triangle ADE upon area of triangle DEC, which is equals to AE upon EC. So we can mark this as our sixth point. Okay. Now what we have to do? We have done everything and we have got these two values. This also we have got in third point, AD upon BD. See, you can see here, and AE upon EC also we have got in sixth point. But we need these values equal to each other. Now they are equal to these areas. So what we'll do now, we have to see this figure clearly, because here if we see I have ADE present in both, but BDE here this is different triangle and DEC is different triangle. So if I divide also, I won't be able to cancel these, because one triangle I can cancel it, but other one they are not same, so there is no possibility. So let's see this figure. We know DE is parallel to BC, and this triangle and this triangle, this one and this one. So can you see that triangle DEC and triangle BDE, they are between same parallels. See, DE and BC, they are between same parallels and their base is also same, both their base is DE. So triangles between same parallels and have same base, they are equal in area. So this is a theorem which we have already done in 9th class. So I will write down here, area of triangle DEC is equals to area of triangle BDE. So why these areas are equal? Triangles between the same parallels, triangles between same parallels, triangle between same parallels and have common base are equal in area. See, their base is same DE, they are sharing common base and they are present between same parallels DE and BC, due to which they are equal in area, and this theorem we have already done in class 9th. So now we have got this thing also. Area of triangle DEE is equals to area of triangle BDE. So this point you can mark it now. Now we will do again division. We'll divide point number 3 with point number 6. Now we'll do division. So again you have to write all left hand side things on left side and right hand side things on right side. So this thing I will just write it down over here, that area of triangle DEC, it is equals to area of triangle BDE. Now let's divide third and sixth point. Third point is also written here and sixth point is also written here. So all the left hand side things I will write first. Area of ADE upon area of BDE. This thing I have written. So step by step we have to do so that we can write each and everything properly. So I have to divide this with this. Area of triangle ADE and area of triangle DEC. So left hand side things I have written first. So this is the bigger division sign. There I will write AD upon BD divided by AE upon EC. So now whenever such complex fractions come, we already know such type of fractions. When A by B it's getting divided by C by D. What you have to do? Just multiply these two and multiply these two, which means you can multiply A with D and multiply B with C. So you have to write in this way. Whenever such complex fractions or two fractions you have to divide, just write in this way. A divided by B and it is getting divided by C by D. Upper terms, I mean outer terms, they will get multiplied with each other, and this inner terms they will get multiplied with each other, which means A into D. So this also we have to write in this way now. So these are inner terms and these are outer terms. Same way these are inner terms and these are outer terms. So I will write area of triangle ADE into outer terms. I am writing DEC. Inner terms now, area of triangle BDE into area of triangle, both inner terms, triangle ADE. Now this side AD into EC, outer terms, BD into AE. You can see now area of ADE cancel with area of ADE. We have already proved that area of DEC and area of BDE, see, both are equal. If they are equal, they both are equal, we can cancel these two also. Cancelling all the terms, I am left with 1. So now 1 is equals to, because all the things they get cancelled, so here it will be 1 now. 1 is equals to AD into EC upon BD into AE. So this is the result which we have got. Now what was our requirement? Our requirement was AD upon BD is equals to AE upon EC. So this was our requirement. So what we have to do? We'll keep AD upon BD one side and remaining terms will shift to other side. If A is getting divided by this term, I mean cross multiplication will take place. Simple. Numerator, if we are shifting to other side, it will become denominator, and denominator, if we shifting to other side, it will become numerator. So I will get both, they will get multiplied by 1 because 1 is present here. 1 into AE upon EC is equals to AD upon BD. So 1, if you multiply, you will get the same term. Can you see now? AD upon BD is equals to AE upon EC. So we have got the required result. Just you have shifted this thing to other side. On shifting, your numerator has been changed into denominator and denominator into numerator. So after doing all these things, we have got our final answer, which means we have proved the theorem. Let's do theorem 6.2 now. It states that if a line divides any two sides of a triangle in same ratio, so this thing is given to us, then the line is parallel to third side. So let's write what is given to us and what we have to find or what we have to prove. Given is this side or this line. So it's written if a line divides any two sides of a triangle in same ratio. See, two sides of a triangle are AB and AC. So this line is dividing AB and AC into same ratio. So I can write it down in this way. AD upon BD, it is equal to AE upon CE. So this thing is given to us. So what we have to prove? If this line is dividing two sides of a triangle in same ratio, then the line is parallel to third side, which means we have to prove that this line is parallel to third side of the triangle, which is BC. So to prove, it is equals to DE parallel to BC. So we will proceed in the same way like we have completed the previous theorem. So can you see this one thing, that this thing was given in the previous theorem and this we have proved. See, this is telling us that this theorem, it is completely opposite, or we can say this is converse of the previous theorem. Opposites we have to do now. So now let's write construction. Same way, step by step, everything we have to write whenever we are doing proof of a theorem. So construction, here what we'll do, we'll draw a line DE dash such that DE dash is parallel to BC. So this construction we have done from our side. Now let's do the proof. So we'll start from our construction part. We'll write, since DE dash, it is parallel to BC, therefore AD upon BD, it is equals to AE dash upon CE dash. See, and this we have learnt in the previous theorem. In the previous theorem we have already learnt, if a line is parallel to third side of a triangle, then it will divide that other two sides in the same ratio. That's why if these two lines are parallel to each other, this result we will get according to the previous theorem, which is also known as basic proportionality theorem. So you can write reason here. Everything whatever you are writing in theorem, you have to write reason for it. So it is because of basic proportionality theorem, or I can say our theorem 6.1, which we have already proved. So this result we are using from that theorem. Now this thing is given to us. I'll mark this as point A and this I'll mark as point number second. Now from first and second, we can see AD upon BD, it is equals to AE upon CE, and AD upon BD, it is equals to AE dash and CE dash. So this thing is telling me that this AD upon BD, this is a common term which is equal to both of these. So if both of the terms AE upon CE and AE dash upon CE dash, they are equal to AD upon BD, this means they are equal to each other also. So whenever two terms, they are equal to a common term, these two terms, they will be equal to each other. So I can write from first and second, AE upon CE, it is equals to AE dash upon CE dash. So this is the result which I have got. Now AE upon CE is equals to AE dash upon CE dash. This we have got equal from first and second. These points I have mentioned. So what we have to do? Add 1 on both sides. So this 1 is not this one. This is number 1. You have to add 1 on both sides. See, sometimes whenever we are proving theorems or we are doing proofs in the questions of geometry, we can use this. I'll explain you why we can add 1. So let's do it. Left hand side also you have to add, and right hand side also you have to add. AE upon CE plus 1 AE dash upon CE dash plus 1. And whenever you are making any change on both sides of the equation, it won't create any difference, because same things means this and this will get cancelled, so you will get your original terms back. That's why always remember, whenever you are making any change in the equation, just make that change on both sides of the equation. Now we'll just solve it. So we have to take LCM here. LCM of CE and 1, it will be CE, it's understood. Then LCM we have to divide with the denominators, we know. So this answer we have to multiply with the numerator. CE divided by CE we get 1, and 1 we have to multiply with the numerator. CE dash, when you divide CE, when you divide it with 1, you will get CE, so you have to multiply CE with the numerator. So I will write this. So I will get AE plus CE upon CE, this side. This side same way we have to do. LCM of CE dash and 1, it will be CE dash, so I have to divide LCM with both the denominators. CE dash divided by CE dash, it will give us 1, so 1 we have to multiply with the numerator. CE dash divided by 1, it will give me CE dash, so I have to multiply this with my numerator. So same way I will get AE dash plus CE dash upon CE dash. You can see. Now let's see our figure again. So this was our given figure. A, B, C, D, E, and here point E was there, E dash. So if you add AE, see there is AE, if you add this AE and CE, this is CE, you will get AC. See, two half lines when you add, you will get full line. See, this is AE and this is EC. When I am adding two half lines, I will get full AC. So AE plus CE is AC upon CE. I will write as it is. Now AE, this half line and this half line. So again when I am adding these two, I will get AC. You can see AE dash plus CE dash, it is equals to AC full line. So I will get CE dash. So which means, see, I am getting same AC and AC on adding this, which means point E dash and E, they coincide each other. They coincide each other. Coincide means they lie on the same point. So if they lie on the same point, as we know, DE dash is parallel to BC, and if E dash and E, they are same point, then we can write therefore DE is parallel to BC. So this was required and we have proved this. So now we have completed two theorems, 6.1 and 6.2. So the results of these theorems we will use while solving the problems or while solving the questions, we can say. So I will do the questions which are based on these theorems in the next video. Till then, if you have not seen video of 6.1 exercise, you can see, and I have given the link in the description box. So see you in my next video. Thank you so much for watching it.